One. Welcome back, listeners, to Cyber GPT Pulse, the podcast where we delve into the world of cybersecurity and allied sciences. We are unraveling myths and shedding lights on the real world incident, as well as sometime reverting back to some latest technology, which is actually deeply impacting our digital life. So, I am your host, Amiruddin Sayyed. We are today. I am with me. Joining is Mubaris Khan, who is a software engineer and specializing in backend development. So, Mubaris, do you want to add to that with your vast knowledge in programming and software engineering?
Thank you, Amir, for having me. Um, yeah, I am very passionate about the world of backend development and DevOps and basically infrastructure in general. And really excited for this podcast. We can get started.
Okay.
So
Yeah.
I think I can start
So,
talking about,
yeah,
yeah.
Bhuvaris, so uh, just for our listeners, this is a new series of podcast which we are starting with uh, an angle of bringing new guests. Today, you are our first guest in that series, and the main topic or the main focus of this podcast will be uh, GPT. So, why not? Basically, uh, the evolution and the future of LLM, not just GPT. So that's kind of the focus we are trying to keep. So yeah, let's start with your thought on that. What do you think?
Yeah, sure. So before this whole GPT thing like literally exploded on our faces, back in the day it used to be all models based on statistical methods. So there used to be the n-grams model that was super popular back in the day, and it basically worked on probability of sequences of n words. So even though it was quite effective for small scale tasks, but it did not do well on large amounts of text, and it was not really scalable. So after this phase came the emergence of neural networks, which a lot of people in the world of uh, machine learning are well aware of. So uh, it was the 2010s when the models like Word2Vec and Glove were introduced, and they essentially just transformed the uh, representation of words from text into vectors, and that changed the entire landscape. So you could capture the semantic and syntactic relationships in the language, and after those came the next models, the RNNs and LSTM models. So I'm sure you are very familiar with the RNNs, and I think you also have experience with them. Maybe you can add more about the RNNs.
Yeah, so in past life, maybe before getting deep into cybersecurity, I was pretty much in between interested with ML and data science. So from that perspective, of course, with the semantic analysis and the relationship study, the study of semantic analysis, ontology, sorry, no, not oncology, ontology has been recently in news because of NVIDIA's keen interest in applying it in one of their own technology. So yeah, that was the key which where words were being embedded for identifying the next possible, basically what LLM is doing, so prediction of the words and embedding them into the tree and generating the tree. So, but RNN basically was for the sequential learning and handling the sequential data within the basically capturing the context, improving the computational calculation in that of basically if you are having if you are having four words, and then from the word one, increasing the bracket to the word four, and then having that contextual understanding from one word one to word four, and then making that dependency of word one to four whenever any anything comes around in that context in any other sentence, and then tagging along and backtracking to that. So that was the basic idea from LSTM, although seems like very efficient. And it initially in 2013 to 2014 or 15, it was very popular in the research field. Even I was involved in it, in that. But being the research parameter, LSTM has a very bright limitation, which was deducted. You cannot increase your accuracy over the time, because even if your long range dependency which you have created, that will be having a lot of overfitting when you are training it, and yeah, that's actually decrease the whole efficiency of the model. So yeah, from that perspective, I think in 2017, that's why Google Research was working toward having a new total approach, better than that. And in place of RNN, transformer architecture was proposed in the all in the attention in all. You need a revolutionized paper, which actually changed the NLP paradigm in various ways. So I think, Mavaris, you have been very in touch with that paradigm. Do you want to share on that?
Yeah, sure. So, like Amir just mentioned, the attention is all you need paper. It literally transformed the entire landscape of the LLM research, uh, and we are where we are thanks to that paper in many ways. So, uh, so it enabled models to focus on relevant parts of sequence, and it would capture long range dependencies in a sentence quite efficiently. So, uh, another key feature that uh, enabled this transformation was the parallelization. So, it made training for massive data sets faster and more scalable. So, earlier you couldn't process large corpuses of data in parallel. But now with this new model, you could do that. And this gave birth to a series of GPT models. So GPT is it stands for generative pre-trained transformers. So OpenAI heavily uses the GPT models. In fact, all their models are based on the GPT models. Starting the first models that they launched was way back in 2018, which was the GPT-1. So they introduced unsupervised training in as part of GPT-1, and in GPT-2, which was released the following year in 2019. So GPT-2 was it was a landmark moment. So it also sparked discussions about ethics and future of work and a lot of things. So it basically was about 1.5 billion parameters, which was like really large for that time, and it just leaped forward the results from the models that were there at the time. So, uh, and the year following that, which is 2020, was everybody, a lot of people know about this. GPT-3 came out. So, GPT-3 was significantly better than GPT-2. It has 175 billion parameters, and you could do few shot, and few shot was okay, but zero shot was really good for a variety of text related tasks. So it was also very scalable, and the performance wise, it was really great. So we have talked so much about all these GPT models and how OpenAI released them. Amir, can you talk about the fundamentals of language models, what they are, and why they are so important in this age?
Yeah, so uh, from the genesis of human being able to talk with each other, we are being understanding how to talk, how to actually start thinking in the thought process, which actually later on converts into the whole discussion into AGI and stuff. But language model was initially thought about that, okay, if we can at least generate and understand the text which we are which, yeah, a model is generating, then maybe that can be a very super smart assistant and can predict the next sequence of statement. And if this can be achieved, at least we will be solving a part of the problem, and later on we may be able to have a general AI. So that's was the focus. And with the advent of transformer learning, which doesn't rely too much on hyperparameter tuning, which was the main basis of the whole testing the data. You have to just hyperparameterize tuning and make the uh, make the make the selection of prioritized parameters. In place of that, right now in language model with transformer, you don't have to do that. It's all coming through the uh, model itself from encoder and decoder layers. So this enables us to able to learn a large amount of data with large amount of parameters or attributes itself, as well as learning patterns out of them. So this helps helps the model to understand the language itself. And this has been very successful with the various use cases, be it communication, having the chatbots being able to uh, just converse with us, like in the advanced voice mode of ChatGPT, we can have the conversation in various languages, which was a very difficult task till 2010 and 11, where for every language you have to have a manual annotator which need to annotate that training set with that language understanding, and then only the contextual understanding of the model can be increased, which is not the case here. So we can just share the training data, and with from the training data, the model is able to find out the parameters which will be useful for the model to actually work better. So that's whole the first use case of communication. And various other productivity tools are also using it. Uh, Everyone knows about Grammarly. Grammarly has been here from a long period of time, but after GPT, the efficiency of Grammarly has been so much increased. The contextual understanding. Initially, it was just able to autocorrect, and now it is able to give the reading comprehension as well. So you can change the tone of your statement depending on your requirement. Of course, you have to use the premium version there, but that's always the part and parcel of the game. And from other perspective, this is also useful for bridging the gap with lesser able people or with the language barrier. Various other tools are being generated. And also one of the even if with we talk about the movie perspective, even iRobot was very cynical about having robots or AI being able to generate creative art. But we are seeing that through DALI and other, even Miro AI is able to generate brainstorm ideas and create own stories, and DALI is able to generate various images. Although the originality of the thought is still debatable, because the annotation of the thought is based on the art or the creative components given to the model. But still it's looks like it's very seamlessly look like creative. So I- from these various use cases, we have a plethora of tools here, and uh, I think Novaris, we should also discuss with various LLM competitor. I suppose most of the listeners might be knowing one, but yeah, let's see how many others are there which are also useful.
Yeah. So broadly speaking, there is I can visualize it in two broad categories. One is your the big tech companies, and on the other hand, you have open source models,
Yeah.
which are also being pushed by the big companies, but you have various versions and various flavors that are being fine tuned and developed by people, ordinary people like Stanford labs, and you have various labs around the world. So, in terms of the big companies, the top notch ones are like the number one is probably it's a battle between Claude and GPT. Uh, and then you have other really promising models by Google, the Google Palm model, and you have the open source model by
Yeah.
Meta's Llama.
But just for brevity, there Google Palm model has been renamed to Gemini, so people might not be understanding. But yeah, it's actually based on Palm.
Yeah, yeah, that's right. Yeah, so those are the main models that are out there in the market right now, and uh, for my most day-to-day tasks, I use either Chat GPT or I use the Claude. So now that we have talked about what's out there, there is also the talk of how competition is driving the LLMs for better efficiency and better output. So what are your thoughts on that?
Hmm. Yeah, so that's a different story from being open source to many. One of the companies that has been moving into closed source. So these are some computational aspects which people are always discussing with being very bright in the news. But from my own point of view, I think it has been segregated in some bullet points. First one is because of the success of ChatGPT in 2000 December 2022, the shift of the R&D, which was initially just to have this AI research, where we are still looking for better adversarial learning model, better reinforced model, which will be helping to have our own self-serving robots. But now that has been shifted into having an much better, cheaper, cheaper GPUs, and which can support energy efficient prompts. Of course, for the LLM model, we require energy efficient GPUs to reduce the cost of training, which has been already reduced from 3.5 to latest O1. It has been reduced, I think, by 70% already. So that's the result is already showing. And from Nvidia, for example, they are having their high end high end GPUs and TPUs ready for training these AI models with faster iterations. And secondly, for the faster processing, of course, the energy crisis will be also there. So because of which energy efficient prompt engineering is required to have the more structured approach and maximize model output, as well as having nuclear energy or more renewable energy available to have that support in future. So that's the second push in the industry, as well as for uh, from the public perspective, as the any for any testing of software or model, when it has been tested by the real user or the general public, you get much more better perspective. And same is going with a GPT. With wider pool of data, it has been able to learn and enriches massive data set, and the real world scenario has been better annotated. But although with this advantage, there is a major disadvantage of having regional dialect and slang mispronounced or misproduced by ChatGPT, creating issues in ethical form, where some racial bias or something has been read from the data or from the users can be reproduced. So because of that, strict ethical policies and governance policy has been already implanted, as well as from various country, be it EU or US, already have AI acts, which is making these AI companies comply with those. So yeah, Whereas, do you have any or more ideas or point to that? Let me know.
Yeah. So another thing is uh, the idea of fine tuning the models, right? So as we are seeing, there is a lot of generic models out there, right? And for example, you need your LLM to do a specialized task. You might be in the finance industry, and you might be interacting with a lot of financial data that I mean, and the financial world itself is very vast. So uh, you could ask why you would choose some models over others, and why some models are better than others. So uh, so the first reason there could be the training data on which the model was trained. So, for example, if you are providing several petabytes of data to a model, and whereas to another model, you probably only provided a few gigs of data. So, the data that the model that was trained on larger amounts of data, the model that has seen more cases and it has got the opportunity to learn on more amount of data is going to outperform. And the next thing which determines the output of the models is the architecture of the model itself. So, for example, in it is rumored that for example, GPT-3, it was trained on 175 billion parameters, right? And now it is rumored that GPT-4 was trained on more than a trillion parameters. So uh, that's why you could attribute its success to the architecture of the model itself. And then you have different fine-tuned adaptations of the general models. Like I mentioned before, if you have very domain-specific task, you can have a very fine-tuned models which could be even smaller than your main model, and it would still perform better because it was trained on your domain-specific information. Then you have certain tasks where you might be interested in getting larger outputs. So, uh, in such cases, the context length of the model also is very important, and the larger context length models are very useful there. So, uh, yeah, I can hand it back to you, Amir.
Yeah, so I think that's really good uh, pointers which you have with how these models compare with each other commercially as well as theoretically, having the fine tuning fine tuning a very important aspect over the parameter size, because with the parameter size this has been seen, although the result is better, but the efficiency of the model is decreasing. So yeah, with that, we can conclude this episode of our podcast here. I hope the listeners found it useful. And thanks for joining us, as well as don't forget to subscribe for more of insight into the world of cybersecurity, as well as latest information. And we will also dive into some aspect of LLM security and ethical aspect in coming episode. If you have any question or topics which you like to discuss, let us know in the comments, and there will be some show notes links which might be useful for you if you want to dive any of these topics which has been discussed in this episode. Stay safe, stay secure, and protect your digital world. And yeah, virus.
Bye.
Yeah, catch you later in the next episode.